well, I guess morning, afternoon, and evening to everyone. I think even our panel spans many time zones. Welcome to the panel on the future of database education. Is the cow book dead? My name is Zach Ives. I'm at the University of Pennsylvania, and I have the pleasure of being the moderator of the panel and introducing the themes. I think a lot of us, as Pinar was saying, have been having this discussion in our own universities as academics, which is, what is our role in computing moving forward as academics? I think if you look at how we've always viewed ourselves, right? We're the data people, but I think in many scenarios, we're starting to find that, we're not the only people who are claiming that position anymore. And in fact, machine learning and generally big data, data science, AI, these are the things that are really catching students' excitement. There's kind of this general feeling that yes, databases are important because they pay the bills and bring in the money and solve important problems, but all the cool stuff is elsewhere. And when I talk to students, especially undergrads, they tend to view, relational databases are flat and tabular and boring. All the cool stuff is in data frames and CSVs and no SQL. Why do we want to handle tabular data? What about text and NLP and images? And of course, increasingly, SQL is viewed as a way of getting the data out of basically a database that's a big table store and turning it into the place you really want to do things, which is Python and Pandas and PyTorch. So there's a little bit of a question of, are we now marginalized in this big picture? How do we want to define ourselves? Are we the dirigible that was once a very important technology and then became marginalized to the point where, it literally went down in flames? Or are we reinventing ourselves to be at the center of everything? So that's really what this panel is focused on, questions along those lines, right? And I think it's also worth noting some of the context here. Many of us are realizing that, especially in academia, computer science is now moving from, 35-person departments, which is what many of the more senior of us are used to 90 and 100-person plus schools of computing. The field is broadening. It's potentially forking into data science or overlapping with other efforts in data science, depending on your institution. So at the end of the day, where is the data science field? Where is this thing that's now being called data engineering, which isn't quite what we imagined when we named ICDE? So are we part of data engineering, data science, computer science, et cetera? And then, of course, if you look around, almost every university, I think, will tell you that the machine learning courses are where everybody wants to go. And in fact, more than half of the PhD applicants, anecdotally in many places, are trying to get into machine learning and AI. So I think as we think about the context of our field and its role in academia, it's also important to realize that, a part of our success in telling our stories and defining who we are affects our ability to continue to recruit the wonderful talent that we have in our community. So this discussion is academic, but I think it's, in fact, also very pertinent to the broader health of the field. So I think really some of the things that we thought were essential here were to try to sketch out some ideas of how we might rethink what we're teaching in the database course or in a data course, if that's a new thing. Do we double down on kind of our core things? Are we basically going to be like, let's say, theoretical computer science, where we say, we know who we are, let's stick with it? Should we retool as kind of broader ML and NLP plus storage people? Should we branch out in a new direction? Do we fit in computer science or data science? And more generally, how do we attract talent? Okay, so with that background, I want to introduce our distinguished panelists. I'm going to start with Johannes Goerke, who's a technical fellow at Microsoft. I think basically the vast majority of us actually are very familiar with Johannes's book, which probably just about all of us use. This is, of course, the cow book that we referenced in the opening slide. Johannes has a unique perspective on all of this, having been a longtime member of the renowned Cornell database group, then doing a startup, and then spending time leading a number of different teams at Microsoft, both in product and research. So he has a really broad perspective on all of this, and I'm especially intrigued to hear what he has to say about the cow book. Next, I'd like to introduce Jana Geseva, who's assistant professor at the Technical University of Munich and a core member of the Munich Data Science Institute. She works on designing cloud-native database systems at the intersection with modern computer hardware. And when she was at Imperial College London, she led a redesign of the computer systems curriculum. And obviously one of the key areas which databases is kind of reinventing itself is at this intersection with hardware. In fact, we just saw the Test of Time talk, which was very much along those themes. Arun Kumar is assistant professor of computer science and engineering at UC San Diego and a member of their Data Science Institute. He works in data management and systems for ML. Through his time at UCSD, he's created 3 different database-related courses and helped design a new master's in data science. And he's a co-author of a book on data management in ML systems. Finally, Rachel Pottinger is professor of computer science at the University of British Columbia. She works on data understanding, exploration, integration, and metadata. And she is a former associate department head and helped lead the creation of a data science minor. So across our panelists, we have a wealth of different backgrounds and lots of different insights to be offered. So with that introduction, I would like to give each of our panelists a chance to give a bit of an opening statement on their perspective on things. I will try to host their slides and move them forward to the best that I can. I'm going to start with Johannes because, after all, we mentioned his book to start, and we'd love to hear what he has to say.
Great, thanks, Zach. So I want to start out by saying that we are extremely successful as a community, right? So all this doom and gloom, I don't completely believe in it. And even if we define ourselves as the database community, we are extremely successful, right? Depending on who you ask, today's market of the database industry is about $60 billion and expected to double in the next 5 years to $120 billion. People with our skills are extremely highly in demand in industry. We cannot graduate enough students that have the relevant skills. There's huge investment by the leading cloud companies, one of them who I work for, into data infrastructure. And since data lies at the cloud, the core of any compute in the cloud, there will be even more investment coming. And then there's a ton of innovation, even out of the startup ecosystem. We just heard about this, including major companies that have gone IPO. Just think about Snowflake or the rumored next funding round of Databricks. Next slide. So there's also a ton of excitement around data science, right? And this is what this whole panel is about. And this is, of course, due to great achievements, really great science achievements, but also with great storytelling, right? Think about beating the Go champion, but also real economic value that's being generated, right? There's all these studies that say that, compare AI to like the steam engine or robots, which boosted GDP between 0.3 to 0.4 absolute percentages, like in the 1800s and then 1980s or 1990s. And many people believe that AI will do something similar, but maybe even over 1% absolute percentage over the next 10 years. And that's real money for the world, right? And because of all of these successful applications and all of this economic value, there's a lot of interest. With this interest also comes hype. And especially I believe that, beyond the hype, there are actually differences between data science and database systems. And this difference is actually there a little bit like it was before, even in the database community, right? For data scientists to be successful, you really need 2 parts. One of them is the infrastructure, and that's the tooling. And the other one then is the knowledge of how to use that infrastructure and tooling. And really the analogy is similar to what we have in database systems. We have people who use database systems and who build amazing applications and innovate in the space and do really interesting data modeling work and really interesting large-scale architecture work. And they have very different skills and very different education than people who build the infrastructure, as compared again to the people who innovate on top of it. So in my opinion, there is no question that our community should expand beyond traditional database systems towards data infrastructure in general, which of course includes data science infrastructure. And then of course, given the breadth of our community, given that we have a lot of background also in techniques that go beyond our traditional skills in systems, in languages, and in abstractions, also towards statistical techniques, that we should also expand into data science. And I think a great example where this has happened is the systems community. Like, just look at SOSP and OSDI. What kind of legacy names? ACM Symposium on Operating System Principles, right? Usenix Symposium on Operating Systems Design and Implementation. So think of any undergrad who is joining, the broad, the university day where they think that operating systems is where the most some of the exciting innovation is happening. And, they will clearly look at you very strangely. But what, they forget is that SOSP and OSDI as a research community, they don't define the field as operating systems, but they're a set of amazing researchers who have really moved on with the times. And, many of our community have written, papers in that community and count themselves as part of this community as well. And I would even argue that maybe some of the most relevant, highly relevant data systems work has come out of these communities, in the last 2 decades. So I think the point that I'm making is that we should define ourselves by our community, by the people, by this great set of skills that we have. And then we should let our research and what we teach also be defined by what the world needs rather than putting ourselves into a box. Next slide. And so what does this mean for, once more?
Sorry.
And once more. Okay, I thought I had some other, I had the cowbook up there again. But what does it mean for,
I think there's one more bill, yeah.
Okay, good. I thought what it means for education is the following, that, the skills that we teach on the systems, on the language, on the abstraction sides, they are more relevant than ever. Right? We can go into more details later, but the idea that you take a program in a high-level language and create a very efficient, computation plan out of it is the core of everything in data science as well. In addition to relational database systems as the core instance of a system where these ideas manifest themselves, we now have really other important large industries, especially sort of the data science industry, where we could also teach these ideas in other, for other systems classes. But by the way, this has happened already for a long time, right? There was MapReduce, there is key value stores, there's graph databases, stream database systems, and so on. And I think of data science just another one of these. And they have different economic impact, and data science has huge economic impact. So therefore, it's just really important. So that's the infrastructure side. And there's the question of the skills of using this system. And there, in addition to the database application programmers or enterprise solution architects, right? There's now this new profession of a data scientist. And maybe a data scientist is actually more interesting to teach because there are more foundational concepts that go along with it, rather than enterprise application architects, which is maybe a little bit more about practical knowledge. And again, since this is an area with a lot of demand, I don't see any reason why anybody from our community who's interested in that growth and that excitement should not grow in that area, redefine that area, and position themselves as proficient in this area. And so maybe in summary, I believe that the techniques in the cowbook, are really still relevant. I mean, they're really overdue to some additions and maybe some dropping, but they're still extremely relevant today. They need to be repackaged in a modern terms of like cloud data and cloud data science infrastructure, with different properties, program abstractions on top of them, but things like transactions, recovery, analytics, associated data structures and algorithms, dealing with memory hierarchies, they're super relevant today. And this is still the core course on data infrastructure, the way I see it. And then on top of these, there are other courses. And by the way, these are really orthogonal that use this infrastructure. There could be a course in database applications. We actually used to have one such course at Cornell. Another one, of course, now could be a set of courses on data science. And there could be huge demand for such courses as well. I want to conclude with one last thought, because there's always this thought of a data course. And actually, in my last years before I left Cornell, this was something that I was thinking about as well, right? So I think what data science and machine learning has brought to the field of computing is this amazing set of storytelling, right? That goes beyond, enterprise applications, but really storytelling that touches everybody's lives. And, that you can tell a story about how it impacts the world, how it makes the world better. And I think, therefore, for the very first time, and not maybe for the very first time, but I believe that with data, we have the ability and we have the chance to teach an introductory course that is full of interesting applications, where we have great stories about the power of data and data infrastructure, even for freshmen. And I don't think this is a database or data science course. This is a course that inspires students to join the field of computing, that teaches the beauty and variety of data, a course that shows how data is at the core of today's economy by talking about content creation, about data collection, data privacy, the power of data, that introduces data-driven decision-making, maybe data analysis and data privacy, but really tells stories with data and shows the beauty of data and computing. And this could be a course that's really inspirational to undergrads, and undergrads maybe who traditionally don't come into computing, but maybe through data science, see a way into computing and therefore are inspired to make the world a better place with data. Thanks.
Thank you, Johannes. Jana, would you like to give some of your perspective on this?
Yeah, well, it's difficult to follow after Johannes, but I'll do my best. So sorry, no slides from my side, but I have a 2-minute opening statement. So I have to agree with everything that was said so far. I think we've come to this panel because we are fearing that we are under the popularity attack of data science, in which case we are not, right? We should not really try to make databases fashionable again and do the lazy way out or the easy way out by adapting to trends and embracing this data science wagon. Instead, we should engage with students. As Johannes said, we should be the storytellers, right? So we should tell them about what is exciting and show them about what are the interesting challenges that we have in modern data management. So indeed, data science, ML are just a piece of the puzzle that they were exposed to because of that great storytelling, but there is so much more out there, right? So we have data privacy and security. We're running these applications in the cloud, on the edge. We have a ton of other different types of workloads that impose interesting challenges. And of course, modern computers look a lot different today than they were 20 plus years ago when we actually load the foundations of these textbooks. So there's so much more that we could get them excited about, in addition to what is the power of what one can do with data. So how do we prepare students best for industry and academia? Should we stick to traditional textbooks? Absolutely, we have to teach the fundamentals. And yes, we may need to rename ourselves from databases to data infrastructure, but these fundamentals have to be taught. And again, my points are similar to Johannes's, the languages, the abstractions, this organizational thinking of how we build systems are even more relevant today than they were in the last couple of decades. And it's just because of these tectonic plates moving, not just from interest of students, but also in what we see in, from the hardware side, from the system side. We're experiencing blurring of boundaries across the system stack. So it's absolutely necessary that we don't go back to dark ages when these fundamentals were not yet invented, right? Because otherwise we'll be going in circles and reinventing them over the next 10 years. So sure, writing something in Python is easy, but the Python script after 2 years is already outdated. A SQL runs still the same after 60 years. So there are so many powerful things that our community came up with. There's a wisdom that we can show our students to how to build and design the future data infrastructure that have to be preserved. But sure, we need to adapt them to today's context, but the fundamentals have to remain.
Thank you, Jana. Inspiring words. I next want to give the floor to Arun.
Okay, thank you. So I agree with both of what Jana and Johannes said, and Johannes had a very long monologue, but so many words of wisdom in that monologue. It was amazing. One thing I should start with is I'm going to be more provocative, probably, and pull out the fireworks, because we need fireworks in the panel. I'm going to flat out say that most of the database education that I'm seeing at most universities is outdated. It belongs in the last century. People are still living with a half a century old mindset of what database field is. And here's a meme that I created. So a first meme that I created on my Tumblr. So go check it out. Even today, 80–90% of the community uses the term database very wrongly. And that is part of the narrow-mindedness that I'm seeing in this community. A database is not a system. Let that sink in. Database is an organized collection of data. That's it. How it is used, what it's used for, is entirely our community's prerogative. Relational or SQL is one workload. There's ML, there's other data science workloads, there's scientific computing workloads. There's so many things that people use databases for, even if they don't use SQL or relational DBMSs. All of that is still part of our community. Data integration, data cleaning, data preparation, all of that is part of our community. Data privacy, data provenance. We had a wonderful talk by Susan, very inspirational. All of that is part of database community. There is a relational, what shall I say? I'll call it the RDBMS supremacism. It's like people think that database means RDBMS, database means SQL. I consider that a form of supremacism in the database community that should be abolished. Okay, so that's an narrow-mindedness. The database area must be reborn in this century as one of the fundamental bridges between computer science and this emerging interdisciplinary field of data science. Everybody who thinks data science is a fad or it's just a passing thing is going to be the same way that people who thought computer science was a fad were mistaken back in the 70s and 80s. That's my philosophy. At UC San Diego, we have invested bigly into data science. We started the HDSI, the Halajulu Data Science Institute 3 years ago. It's an academic unit. It's its own department and its division. It's not under engineering or social science or anything else. We have grown phenomenally in the last 3 years, and now it's on par with any top 10 computer science departments. We managed to attract folks away from top tier computer science departments in the US and abroad as well, in all sorts of areas, databases, ML, AI, statistics, viz, and multiple kind of philosophy, data ethics, and so many areas. And we are powering ahead. HDSI just got a 20 mil National AI Research Institute in a kind of grant. And these sorts of universities that fail to invest in data science are missing out, and they're going to keep missing out, just like universities that fail to invest in computer science are still missing out. They're failing to catch up with the universities that did. And I think the database area is one of the key bridges alongside machine learning, data mining, AI, data viz, and I guess data systems like more broadly, not just like cloud computing, kind of bridges systems and databases. So to reflect that diversity and the growth, just like Johannes said, I think we should not shoehorn databases into one single course. It's impossible. It's like saying computer science should be shoehorned into one course. That's not possible. So, if you make it, it's going to be super shallow and it's going to be boring. Now, of course, you could do an introductory course to inspire and engage and kind of have as a gateway. That's fine. But then you need to have a subtree. You need to have a series of courses that have prerequisites that are well structured. The curriculum should be well designed. The learning outcomes should be precise, that target different cohorts. And I mean different cohorts of technical audiences. Database courses are not just taught for database administrators or data analysts and business analysts anymore. These are not just people who want to learn SQL, relational models, schema design. Data scientists are now a huge fraction of our audience, and we should teach stuff to them. We should teach the memory hierarchy. We should teach data frames. We should teach Spark and AWS and stuff like that. And that's something we've been doing in the courses that I've created here, Systems for Scalable Analytics aimed at data science majors. And it takes apart, like Johannes said, the concepts and the principles that are embodied in an RDBMS and revisits this in the context of data science systems. We also have to teach domain scientists. SQL is still super valuable. It's not going away. People might hate on SQL all they want. It's not going away. So, and it never went away. Some people are delusional thinking SQL went away and then now it's back. No. If you look at all the enterprise companies, they never lost touch with SQL. There's propaganda about NoSQL, there's propaganda about that and this and all that. SQL was always there. People just chose to ignore and not look at it. It's never gone away. It's not going away. So domain scientists also need to learn SQL because data frames and pandas and all these things get really unwieldy very quickly when the complexity of the schema grows. And this is true for data science as well. So we made it a point to teach SQL to data scientists. It's part of their core courses in our data science major. In fact, I am pushing for relational model and relational algebra to be moved to the lower division where they will learn pandas and data frames and connect the two so that SQL can be taught later, but pandas is also taught alongside relational model. The fundamental nature of the relational model means it's useful in many contexts, not just SQL. And of course, there's also data engineers and ML engineers, MapReduce, Hadoop, data flow systems, cloud computing, TensorFlow, PyTorch, these are also data systems. And so we should view them that way and embrace our role in building better systems in this landscape as well, and not just shoehorn and pigeonhole ourselves into just SQL land. And so one last provocative thing I would say is database systems courses. And these are not database principles or design or applications or use. There's multiple kinds of courses. Systems courses that cover the implementation of the database systems should add 3 new core topics. Cloud computing is a must. Cloud native RDBMSs are the future. We all saw how successful Snowflake's IPO was. Databricks is probably going to go next. ML for DBMSs is also very important. We saw Andy's awesome talk. So congrats again to Andy. And database systems and data management for ML is also an important thing for the future of the field. And so these are core topics that should be covered. Now, where do we make room for in a traditional database systems curriculum? What I've been doing at UC San Diego and gotten away with it is just drop transaction management, recovery, concurrency control, and locking. It's not relevant to most of these audiences that I'm talking about, data analysts, data scientists, domain scientists, data engineers, ML engineers. It's relevant for some subset of DBAs, maybe some subset of business analysts. Maybe it could be moved to a separate course on transaction management that can be covered for alongside NoSQL systems and ACID and Base and all of that stuff. So instead of holding on to old last century views, we need to evolve, we need to be reborn. Now, coming last to the point about Cowbook, I totally used the Cowbook for my DB systems implementation course. I think it's really cool, it's really nice. So thank you, Hannes and Raghu. However, it's not enough anymore. I think Johannes also made the same point. Probably covers only about a quarter of today's education needs in the database space. We don't have enough textbooks for some of these emerging topics. And we don't have enough textbooks for some of these emerging audiences, for data scientists, for data and ML engineers. We need new textbooks that cover the data systems principles. And hopefully someone will take it up. I mean, I took up the ML systems book with Matthias and Jun, but that was more of a research thing for graduate audience and research and faculty audience. But we need somebody to write some textbook like that for undergrads as well. I hope people who are listening in are interested in those sorts of things too. Thank you. So I hope that was provocative enough, Zach.
Thank you, Arun. I think you opened up some great threads to follow up on. Rachel, would you like to add your thoughts?
Sure. So good day, time of day, whatever time of day it is for you. I just helped lead the creation of a data science minor. So that's worth noting that I'm coming at this from a bit of the same perspective that Arun is, which is that, part of the minor is a course on databases because databases are not dead. It's very hard to kill databases. People have been trying to kill a relational model since the 1970s when it started. And people will continue trying to kill relational databases, but it's not going away. So part of our minor is a course on databases, but the introductory course contains nothing about relational databases because that's not what data scientists need. So data scientists need to focus more on using data and less on how to store data, and they have less background in programming. As Arun was saying, it's kind of like the difference between we have the applications and then we have the data. And that doesn't mean that we should get rid of the course about how to store the data. That is something that the computer scientists need, right? But there really is a growing need for both. And if you look at what's happening to database research, the similar forces are driving database research, right? You look at the different tracks now that we have, which is that we have the core databases, and then we have data science in some of the major conferences. And this is because we are surveying all of these different needs. And this is why, if you go back as far as JAG's work on doing increasing usability, this is why this kind of research is so important and why we need to teach this and we need to live it in our research. I did want to end on one point, which is about the Cowbook. So I'll note that we actually do use this in both our database for computer scientists and databases for data science courses. But so it's not dead, it's still useful for some need. But I think the more fundamental question is that, unlike Arun, I do not argue that we need to have more textbooks. I would argue that textbooks are dead. And it's a much more fundamental shift. And we need to move on and sort of help people get the information where they need, much like we do with data science.
Great, thank you, Rachel. And thank you to all the panelists, some interesting and provocative opening statements. I want to give a couple of observations / comments about what everybody said in the hopes that it will help us lead to some more interesting debates as we go to some more specialized questions. I think the first thing I want to note is one of the interesting aspects of our community is we tend to view ourselves by the importance of our applications and our impact on the world and so on. And I think that's a very important aspect of who we are. But I would also note, especially as a department chair, there's a piece to this also, which is that we have to argue for the importance of our field and its innovations and where it's pushing CS or data science or whatever within kind of the broader CS community. So I think we can be proud of what we've done, but we also have to kind of continue to have an identity for why we're one of the important cornerstones of CS as a research field rather than as an application field. So hopefully somebody will be able to pick up that thread and take it somewhere. I think a second thing that's always interesting is through the rest of CS, we're often viewed as data scientists. I think actually very few parts of computer science are really data science, maybe natural language processing, maybe web, where you're actually doing stuff with real data over and real analyses of data in the wild. We're much more what's now being considered to be data engineers, or maybe even, as I think Johannes was saying, data infrastructure people. This affects a little bit how we're perceived, and I'm not sure whether we're telling that story that well. The other thing, and this is where I hope we can tease out a little bit in the curriculum, I think as a field, one of our strengths has been crossing layers, but we've also tended to be very siloed about it. It's sort of, if you look at traditionally database community, it's SQL is great. We're going to use SQL for objects. We're going to use SQL for matrices. We're going to use SQL for whatever it is that you want to do. And we tend to own the entire stack. And I think when you look at how we teach the database class, at least in the experiences that I've had with the database class, we tend to look at the database as this kind of self-contained thing. Maybe we do a web server above it, but it's not part of a data pipeline. It's everything is in the database. We're going to use the database, right? So this is a very different perspective, I think, than what data science is about. And maybe that means we need to consider that in everything. I think people are much more amenable to data frames, which have actually spanned both R and Python than SQL. So again, maybe this will be an interesting piece to pick up on. And then I guess finally, I'll note, everybody probably agrees we can add more courses, there are more topics, but part of what I want everybody to consider as we go into the more detailed questions is what is actually going to be on the core part of most of our students' education. So with that, I would like to go kind of through a series of more detailed questions for the panelists, and actually hope that the audience will also chime in as we go as well. I know there were a bunch of questions that have been coming up on the chat, and I think several of these will show up and perhaps be worth pulling out as we go through these questions. So I think the first is really, we're seeing this huge movement of growth in computer science and kind of forking into a bunch of subdisciplines and smacking up against informatics. If CS and data science are evolving and separating as fields, where does databases ultimately end up? I think Arun said it's a bridge. Anyone else have other thoughts?
Looks like everyone thinks it's a bridge then.
Yeah, how about we start with Johannes and then I think Gustavo is.
So I don't know. I don't like that question, right? Because what it feels like, it's sort of, we sort of have to find our place in the world, and I think we have a really, really good and strong place in the world. I think what we should ask ourselves, what is the skills that define this community, right? because I think there are, and I think, just look at the discussion in the chat, there are some areas clearly where you would ask, if you ask somebody about concurrency control and different, isolation models, clearly database systems, right? Normal forms, clearly database systems. So I think if you think about also in our courses, right, what we teach is defined by some of the beautiful concepts that we as a community have defined, right? I mean, you think about languages, declarative languages, and the power and complexity of these languages, right? So I think what we should think about is, right, what is the skills that we as a community can contribute, right? Because if we are a community that, well, we do interesting algorithms on large data, right? That is maybe a little bit less differentiated. So I would try to understand, if somebody joins this community, what is the moat that they build for themselves, right? What is that set of skills beyond having read a bunch of papers that they're really great at, as compared to somebody who is maybe in algorithms, as compared to somebody who's a statistician, as to somebody who is in the SOSP and OSDI community, right? What is that set of skills that we have? And then we should look at this set of skills and see how we can apply it. For example, it makes my eyes tear a little bit when I read an SOSP, a rewrite compiler for deep nets, right? Where there's, deep nets, and then, there are various rewrite rules, and, sort of a compiler that actually tries to optimize, deep neural architectures for, and, why doesn't it come out of our community, right? This is something that, high level languages compilation down. So I feel like, so I agree with Arun a little bit, but maybe I would say it's stronger that, right? I think our community, we sort of don't go back to our core strengths and then apply them wherever we see these strengths can really make a difference, right? And I think what I would, again, coming back to the SSP and OSDI community, what they're really great at is that they're going after the interesting problems and sort of always try to address them with sort of a larger and larger set of tools that they have, right? I mean, there's now lots of papers also on verification in the SSP and OSDI community, right? So again, maybe the point that I'm making is that I would not worry about where we sit as a field, right? I mean, in many universities now, computer scientists sit both in computer science departments and information science departments, right? In other, data science departments. But I think we should think about, how do we distinguish ourselves as a field, and what are sort of our strengths, and what do we teach them, the next generation of people who come into our field, and what are the skills that they need?
Thank you, Johannes. I think Gustavo had raised his hand for a moment.
Yeah, I had a question, but I just let the discussion going on what you are, and then once you are done, I can come up with my question.
Okay, great. So then maybe Jana has your, it'd be great to hear from her.
Yes, thanks. So I personally, yes, we are a bridge between, so to speak, computer science and data science. But to me, data scientists are domain specialists that use data to answer their domain questions. And we hopefully provide them with the tools and with the skill set on how to use these tools and tools and how to get the most out of the data. But primarily, I see myself as a computer scientist because I should develop, and together with my students and us as a community, right, we should develop these systems, these powerful concepts and abstractions. And again, following up on what Johannes just said, we should not just sell our product as a full package, right? We should, in principle, just identify the cool concepts, as I said, the wisdom that we have come up with over the course of the years, and apply them to the relevant problems, and of course have a good storytelling to convince people on why this is super essential. So yes, transactions are super essential, thinking about consistency levels, invariance, about all of these things. As we said, we're seeing our ideas being duplicated in many of the neighboring areas. I also sit in between databases and computer systems, but I also see it, translated in neighboring fields like compilers and so on. So most of what we've done is generalizable to a lot of different problems. The key thing is, how do we communicate that better, and where do we how do we best apply these important concepts for the rest of the broader computer science community. And I'm already beginning with my students. You know, we are rewriting what file systems should look like with the help of databases, because file systems are broken because they don't follow these traditional concepts that we have integrated in our database, right? So there's a lot that we can still contribute to the world, in addition to us facing the existing challenges of our current wisdom. We just need to open the box on how we think, and then apply them, or start applying them in the problems that we see are either the neighboring communities are struggling and so on, right? So we are definitely computer science people, but of course we could help data scientists and domain specialists into their own challenges when dealing with data. But as Rachel said, I see this primarily as as us teaching their minors, data science minor, rather than letting that affect on how we teach data management.
Thank you, Jana. Arun, it looks like you want to weigh in, and maybe we'll make this the last one before the next question.
Okay, yeah, sure. So I think one way to think about our role in bridging computer science and data science is how the computer architecture community bridges electrical engineering and computer science. They see themselves as part of both worlds, right? CSE department here, for example, has computer architects who are also a faculty at ECE, many of them, and that's true for many others. Likewise, we can also think of ourselves as the way theoretical computer science faculty, some of them who do discrete math, think of themselves. They are in math departments. They are also in computer science departments. That's our role. That's our future. We should just embrace it. And mathematicians don't say, oh, computer science is just applied math. That's what they dissed at it in the 70s. And now who's laughing? Which field has more funding? Which field has more jobs? Which field is defining the future of humanity? Likewise, electrical engineering said, oh, computing is just one possible use of our electrical engineering technology. And now everybody wants to reposition themselves as data scientists and computer scientists because that's where the growth is. And so data science is a huge growth opportunity for computer science. Now, there is the definition of an intersection is we are in both. There's no harm in saying we are both. There's no shame in saying we are both. And it's an opportunity we should just leverage and embrace. We can contribute to the growth in the core computing field itself. Like, what is the industrial professional of a computer science curriculum? It's a software engineer, right? That's the pinnacle of a computer science professional, right? Who done a bachelor's in computer science, they become a software engineer. The pinnacle for that bachelor's in data science would be a data scientist. Now, software engineer is not just one role anymore. It's specialized into like 20 different roles. There's software test engineers, software dev engineers, security people, network admin, system admin, DB admin. So many things have come about in the last half a century. I foresee the same thing happening in the data field. Data scientists will no longer be this catch-all one thing. There will be ML dev engineers, ML test engineers, ML data engineers, ML security engineers, labeling engineers. There'll be a lot of people, ML ops engineers, who will all kind of specialize as the growth happens in that field. Now, coming back to this notion of data science is not applied field. If you say data science is an applied field, computer science is an applied field. Because computer science is just applying math, it's just applying electrical engineering. Likewise, data science is just applying computer science, it's just applying statistics. I think we need to get over this. It's just an applied field. It's not an applied field. It's really a synthesis. It's an interdisciplinary synthesis, computer science with statistics and math and CogSci and domain sciences and so many other fields. And one other thing I would notice, some of the highest value, highest impact applications of data science are not in domain sciences. They are in the business work. They are in recommendation systems. They're in social media. They're in enterprise and business analytics. They're in governance. They're in law. They're in, I don't know, so many other nonprofit applications, humanities, digital humanities. Domain science is just one part of the galaxy of application domains that data science has. Just like domain science is one part of the galaxy of applications that computer science has. Now, we don't call a person who is writing a program to build an application for, I don't know, a social scientist as a computer scientist, right? Likewise, we cannot call a person who's just building an application to do an analysis as a data scientist. They need to be grounded in the techniques and the tools and the theory and the systems and the concepts of data science. So I think one of the things that I'm seeing with the realignment I'm talking about is this bundling that has happened over the course of database curriculum design. We have to revisit that. we have to repackage this, and this has to be pedagogically grounded in who are we teaching this for, what are we teaching this for? And that's why I'm saying we need a gateway course and a federation of courses, or a series or a subtree of courses targeting both fields. Like here at UC San Diego, we actually have two separate curricula, one for the computer science major, one for the data science major. The introductory data management course for computer science major covers functional dependency theory, covers normalization theory, covers transactions. But the introductory data management course for the data science, we don't need to cover much of those. We cover data frames, we cover the relationship between relational model and data frames, pandas and SQL and stuff more, rather than dependency theory. Nobody's sitting and doing hand design of normalized schemas anymore. It's all automated tools. We don't teach transactions to the data science majors at all. They can take the computer science course if they're really interested in that. There is a distributed systems course that covers ACID and base for us. So yeah, I think we need to think about what is the purpose, and that goes back to this, what they teach in pedagogy theory, in education theory. What are the learning outcomes? Who are the people you're targeting? What do you hope to achieve with this? And then work backwards from the learning outcomes.
Thank you, Arun. It looks like Tamer has a question or comment, so I will pause for that before we dive into the next question, which actually I think will relate a fair amount to Arun's comments.
All right, thank you. Interesting discussion. With the perspective of about 40 years in the field, I have a lot of different feelings. One part of it is the deja vu all over again issue. As a field, we seem to go through these gyrations of who are we relevant, etc., etc., with some periodicity, and that really pisses me off, to be frank. You know, it's right now it is ML and AI again, but in my 40 years, this is the third wave that follows two AI winters. So, you know, and we're still here. I'm still doing data management, not the same thing that I was doing, of course, 40 years ago, but different. So let me just touch on a few different things. I think the discussion started with, should we adjust our curriculum to one of an existential discussion about the field? And I think we should probably refrain from that existential discussion. I think we're doing very well. As Johannes said, we're critical, and there's a lot of good work and research that's being done. The other issue is this notion of data science, and I think I heard something like data science is not CS. I'm hoping that meant data science is not only CS, which I would agree, but CS has a huge role. And I think we all seem to be forgetting the fact that data science is not data analysis. Data science includes data engineering, data analysis, data visualization, etc., etc. And the data management field has a central role in the data engineering part. You know, I don't know why we skip over that issue quite frequently. You know, the old adage of junk in, junk out applies here as well. If you don't do the data engineering right, you're going to fail miserably. Remember the UK's COVID count disaster, because they were keeping their data in an Excel spreadsheet in a particular way. So they reached a limit and the data was lost. So there is a huge in data preparation, etc., etc. So that's probably an important issue. The third issue is the topics that Arun mentioned about the curriculum. That's being done. That's being done in places where the undergraduate curriculum and the size of the unit allows it to be done. We certainly have 3 courses. We certainly cover even some basic parts of SQL as a language in a non-database course in the second year. And then we have 3 other data-related courses, but that may not be always feasible in other institutions where the undergraduate curriculum is tight. So the discussion then is, if you can only offer one undergrad data management course, what do you do? And I think that's a discussion very, very much worth having.
Thank you. That's in
Thanks.
fact a great a great lead into the next question that I hope is showing up on slide, which is really, in fact, I don't know about every curriculum, but every CS curriculum that I'm aware of does not actually have in the core a data course the way that we would think of it. You know, everybody has a data structures course, but I'm not quite sure that I know of a CS degree where there's a core, either database course or something equivalent. Maybe that has changed in recent years, but in general, that hasn't been the case. So the question I have for the panel and the audience is really, you know, in light of all of this, I mean, I think part of what we all are in agreement about is there is a lot of importance to data management and to database ideas. Is it time for those of us who don't have a database course in the core to change that? And what would this database course or data course look like? Anybody want to start us off?
I mean, is this a realistic, meaningful question? Is there any university that teaches only one course related to data?
No, but the question is, right, so if you think of the core, right, the required courses on a CS degree, right, you've got intro programming, you've got discrete math, you've got data structures, you've got probably operating systems, depending on the specifics and so on. I think the question is, should databases be the core or something else?
We have a comment in the room as well. Like,
so this is Felix. Just very briefly, I mean, maybe this is something that we can, you know, have a questionnaire in the chat briefly. But I think in Germany, from my experience, practically every core computer science curriculum has databases as a mandatory course. Actually, it's not true at HPI, but it's true almost everywhere else.
Interesting. Because that may be regional. So lots of interesting things in the chat. So Arun, is there a core database course at UC San Diego?
Rachel had her hand up. Rachel, do you want to go?
Sorry.
Thanks, Arun. I mean, I think that one of the great things about computer science is there's so many interesting things to do. And the computer scientists are really, and students are really good at voting with their feet. So frankly, I think that the right thing to do is to have as little as possible in the core, that stuff that they need to do in order to be computer scientists, and then let them vote with their feet. We have not had databases as a mandatory course, yet for many years, it was our most popular third-year course, even above our required courses. So I don't think that we have to have databases or machine learning. Neither of them are required, but so many students are going to want to do them. I think that our goal should be to make things exciting and accessible to them, and then the students can do what they want to do.
Thank you. Let's do Abdu.
Hey, this is Abdu. So I'm a teaching assistant professor at the University of Pennsylvania, and I've been teaching database systems for the past, I don't know, maybe 6-7 years. And I totally agree with Rachel. I think it's in the US, everywhere I taught databases. It's basically, you know, we teach, we have it as an elective course, right? But still, I mean, my class goes, this semester we have about 500 students, and they're not just from the CS, they're coming from all different walks of life, right? Because they do understand, and when I ask, right, when I survey my students at the beginning of the semester, some of them taking databases because they want to get into data science, because they realize that this is one of the components of being a data scientist. Now back to Zach's questions. I guess at least me surveying the way we teach databases in 3 different institutes, I guess I've seen different walks of life. So I've seen people teach database applications where they focus on the relational database systems and they just teach SQL, right? That's pretty much what they do. I've seen people that kind of have a mix of database systems where they introduce databases and then they also touch base on the systems part, right? They teach transaction, concurrency, indexing and whatnot. Lately, I start to kind of realize that what Aaron mentioned is actually true, is that databases is not just relational database systems, and we need to introduce students to the fact that we're talking about data models. I know SQL standard the test of time, right? But we're teaching data models. How, I think the power of database people is that we were able to model the data perfectly, starting with the relational database model. So we start to introduce other data models, like the graph data models, and we start to introduce Neo4j for that, and the document data model. And in fact, part of the CS education I do right now is to try to help students realize the differences between data models and the differences between declarative query languages. And I don't know if I should say MongoDB has a query language to begin with, but then, you know, I kind of focus on trying to teach students that here is how we do data modeling, and here is all the cool theories that database people came up with. And it's a fantastic application for students, especially in third year, to see like, here is, you know, a theory that is actually applied, right? Like the relational algebra theory and all that. So I still teach all this stuff. And I do know that the database systems in itself is one of the popular courses here at U of I. And I know that there should be some other complementary courses that also kind of introduce students to modern data management systems and whatnot. So that's what I wanted to say.
Thank you, Abdu. Arun, would you like to respond next?
Oh, yeah, sure. So I think the Gateway Plus series or subtree federated model makes it very amenable for making something a core course. Because on the CC side, we have the database systems. I put this on the chat, to database system principles, where we cover relational model, algebra, SQL, a little bit of functional dependency theory, actually a lot of functional dependency theory, and a little bit of transaction theory. And that's the gateway course from which we have a database applications course. Third, we have a database system implementation course, which is the one I teach. We also have an online analytics course where we teach OLAP and all that stuff. So there's like 4 courses on CSE side, but the gateway course is the core course that's required for all bachelors. Likewise, on HDSI, we have a 3-course series. The introduction to data management drops transaction theory and normalization theory, and instead emphasizes more on data frames, pandas, and more use of SQL for data scientists, including exploiting physical optimization capabilities. The follow-up course is the systems for scalable analytics, which I created. I linked to that. That one is also a core course. So we have 2 core courses from database standpoint for data science majors. And the systems for scalable analytics is really a new course of its kind that I found a need for. Going back to the point that Johannes made, what would a textbook look like if we were to build systems for data science as a textbook? So I revisited everything top to bottom, from computer organizations through operating systems, through parallel data systems. These are the core fundamental concepts that we borrow from database systems, relational database systems, and then we bring it to the data science land. What does parallelism mean? What are the forms and paradigms of parallelism? What does scalability mean? How do you straddle data and model computations across the memory hierarchy? What is cloud computing? What is elastic? To scheduling and kind of understanding what is a scheduler and what is how does Dask work? How does Spark work? What is data flow systems? What are the principles behind what goes on once you run a SQL query or a Spark data frame query? What are the kind of basics of what query optimization means? Now, one thing to note is in the data science land, the tools for scalable data processing are still very primitive. Dask doesn't have a query optimizer. So people still sit and manually chunk their data, manually configure memory, buffer manager sizes and stuff. It's really atrocious. I even tweeted about this. So these database systems principles that we've studied in the relational context absolutely matter in the data science context for all sorts of data intensive computations. Declarativity, kind of, or higher level specifications, logical physical translations, query optimization, parallelism, memory hierarchy, these sorts of fundamental principles of the system implementation needs to be ported to data science. And so that's sort of why we made that mandatory. Now, the optional courses, electives include one on beyond relational data. So that's like semi-structured data models and graph querying models. I think that is very important to teach to data scientists. Graphs are ubiquitous. So graph programming is important and graph data management systems are important. Semi-structured JSON and the sorts of querying languages are also important. That's an elective. We also have one on spatial data systems and analytics. So I think we want to make sure that the core data course acts as a gateway so that it excites people enough to want to able to take these other courses if they want to, but we don't want to make it so shallow and kind of boring. I don't know. That's just my take.
Thank you, Arun. I think Alan is next, and then Sudarshan, and then Ghislaine.
Thanks, everyone. So thanks for a wonderful panel. I do really appreciate the fact that people are spending so much energy and effort thinking about these topics, which are central. I'd just like to make a couple of points. Before I get into the main one, the issues in the chat with people comparing different curricula. I think a lot of people are just not aware of how different the curricular structures are between especially Europe and the US, and a European education where you have typically students for 3 years doing nothing but the courses you've told them is a very different situation from that in the US, where students are doing a major in a generalist degree, and you can't compare. One other point before we get into it, a lot of this discussion of all these possible extra courses, you've got to realize the people who are going to end up teaching those courses are us, and we're generally already overstretched. I think that while it's really, really hard to pick out a subset and package it, we've got to do that, if only in self-preservation, to say nothing of the fact that the students don't have time to take 5, 10 different courses. So with that out of the way, one of the things I've found when teaching data principles to freshman data science students is the importance of getting away from some of the basic assumptions that we have in a traditional database course, which is that you have a database management system, which you put the data in and it has capabilities. So what I tried to do, and I think is a very central thing, is to identify those features, those capabilities, things like access control and a query language and so on, but present them in ways where students can find out that in many platforms, they're going to have to do that because the platform doesn't provide it, but they still need to know it's important. They need to know about the problems that concurrency control is solving, even if the only way they can solve it is to stick their files into a version control system, or even worse, just have immutable files and name them appropriately if that's all you've got. So I think the principles are central, but we should get away from this view that we can have a platform, that everybody can just have a platform that does stuff in.
Thank you, Alan. Sudarshan?
So I want to say two different things. The first is Arun Kumar made a very interesting point. This is from the research angle about how the state of scalable analytics with pandas and so on is terrible. I view this as a fantastic opportunity for us database people, that we know of a huge variety of ways to make things scalable. But if we wait for people to write SQL and then we will optimize it and run it, maybe we are looking at it the wrong way. We should be thinking of allowing people to write things in whatever way they want. And if they are voting with their feet for pandas on Python and so on, so be it. But there is an opportunity here to actually optimize these things in all the ways that we want, so that things will run however big the data is, they'll run fast and so on. So I think there's a lot of research opportunity for us. But coming back to the topic of the panel, the CS education, I think we are, we're like automobile engineers in some sense, and there are a lot of fancy cars which people are driving. But there are two things, right? One is anyone who drives a car needs to know something about how the car works. And our engine capabilities, we need to expose that much to our data science majors who are doing other things. So SQL is certainly part of it. That's part of a UI. They need to know it. They need to know why it is important. They also need to understand parallelism, as Arun Kumar said. So we have to expose them to parallel frameworks and help them understand how it works and so on. But beyond that, I think there is this whole CS audience, which we shouldn't forget. It's not the whole world is doing data science. There are a lot of people building huge, large-scale apps. And if you don't do it right, they die. they work very badly. And the tooling that is out there today is still pretty poor. Of course, it's improving, but I think it's important that computer science students understand this part. So the other parts of the database curriculum, I think, are still extremely important. And in particular, the parts about big data using cloud and consistency issues there are very, very important. If you don't, you're going to get. I've seen applications where people try to optimize stuff using, one of these Memcached and so on, and users found problems. They found that they did an update which vanished. So if you don't have the principles right, you're going to build poor systems. So I think we should keep that audience also in mind and not worry so much about ML eating us up.
Thank you. The next person in the queue, I think, is Ghislaine.
Thank you, Zachary. So I wanted to make, I would call it an orthogonal comment that is very dear to me. We have been discussing how to structure the curriculum, what to include, what not to include. And a lot of us have different opinions, for example, on data frames, whether to include them or not, at what level, transactions, and so on and so on. And I agree, by the way, with a lot of things that have been said. And that what means is we have different ways of teaching them in the universities, between the Europe, between the US, across universities. And I think it's great. I think it's great. I remember it was a few years ago, I saw an article, I think, in one of the magazines in Europe where people were trying to push to centralize education with a single course, shared by everyone at a high level to save resources. But I think on the contrary, we have to embrace this diversity of the way we teach, that people teach their different approaches to different students, because it means the field is alive. And this is how we will make sure that in the future, people will make progress in science with a diversity of ideas and of approaches. And as a second comment, but it directly derives from what I just said, I love to put the historical perspective into the teaching. Like, for example, I love to say that tables are 4,000 years old, with the old clay tablets and so on, and all this way that we came to the way we think, across these centuries of thinking. So yes, I want to say that the diversity of the modes of teaching is something very dear to me.
Thank you very much for your comments. Ioana?
Yes, so as I'm listening to everyone, I think we agree that there are crucial parts of database education that are also shared with other fields, like, for instance, transactions and distributed systems. And, obviously there are bricks or sub-modules that can be learned in different classes and that are needed in order to advance in a database education. So I was wondering if we as a community could produce, or maybe this already exists, a kind of structured understanding of what it takes to get a good data management education these days. Possibly think of a graph, right, with prerequisites, knowing that all of it is probably not offered anywhere because it would be too much, or more than one per student can, reasonably assimilate. But we would have like the whole, let's say, DAG. We would have the whole DAG with tasks and dependencies and requirements, a bit like what Arun said. But consider it large scale. I mean, pull it large enough so that it can get, on one hand, to, off the top of my head, augmentation for information extraction, okay, through ML, and at the other end of the scale to main memory abstractions for programming cross-platform, right? So do you know if such a resource exists, or if we could somehow try to crowdsource or produce one and share it, with the community, and try to, maybe this would also clarify our existential doubts, right? Because we would see that we have a core, there's a centroid of what everybody agrees should be in data science. And then there are border points that are shared with other communities, and that is just fine. All of this is knowledge, and we are making, we're making our students smarter after their courses. Do you know if such a resource exists? Would anybody be interested in joining forces to try to devise such a thing, knowing that, you know, it would be very shallow? So the purpose is not to actually write courses. There are plenty of things for that, but just to fundamentally build a kind of global curriculum view.
So I think it's a great idea. I'm not, you know, it feels like there's lots of pieces to this, but not something that's as comprehensive as the way that you're describing it. So, you know,
So
this
we
certainly
have
could
a
be an
comment
interesting thing that we can follow up on. Sorry.
Yeah, we have a comment from Felix.
Just a very quick one. Actually, I think it's quite okay to have a very diverse, maybe by country or by university or teacher diverse core. If everybody learns the same things, you know, life will become boring.
But there's also a point of interoperability, right? I mean, you need to understand at least what maybe 1/10 of the community that you find that the conference is doing, or otherwise community, you know, will be an empty word. And obviously we do have a lot of core competencies that we share with at least some of us.
Can I just add one piece to that, which is, you know, I think as the technologies and skill sets have changed, right? A lot of us have had to kind of brush up on pieces of CS that maybe weren't in our original training. And I would imagine that some of what Ioana is talking about could also be useful for helping, you know, teach the professors, right? Or at least define where such things can be. Gustavo, would you like to chime in? Oh, Gustavo, your audio is off.
Okay, yes, now it should work.
Thanks.
So I have a question that after all these discussions, I think might actually help to focus these things, right? I mean, the problem that databases have is a problem that many other areas have had, and it's our own success. And if I look at essentially all the books that are out there, right, I would say that they have become database theory books. But not in a bad sense, but in the sense that the realities of how systems are implemented and how things work out there, right, is so far away from what is on the textbooks that it's very difficult to explain to the students, and it's very difficult to convince them that what you're teaching them is what actually is used in reality. And there are plenty of examples of this. It doesn't mean that these concepts are not valuable. Is that the mapping of those concepts to real systems is becoming increasingly more complicated. And now with cloud computing, this over the years, this will become very, very difficult, because in the cloud, we are getting extremely specialized systems, and we are getting very, very diversified systems that are all data processing systems, not databases, but data processing systems. And then covering all of them is going to become very difficult. But this is true of many other areas. This has happened in networking, has happened in operating systems, has happened in distributed systems. It's just in databases, we seem to be stuck still on the database, relational database engine. And until we don't move from there, we're going to have a problem. And I would like to sort of hear comments from the panel on this.
Great question and comment. Anyone want to respond? Looks like Arun.
Yeah, I can respond. I mean, what will it take to have a single course in computer science? Right? It's going to be really packed, and it's going to be really shallow. I think that's what this course will look like. But maybe that's okay. Maybe it's an introductory course. So we have an introductory course for freshmen in the data science major. That's really super shallow. It's kind of fluffy. It just basically gets them inspired to get into data science. We spend a couple of weeks talking about application domains and how data science is transforming the world. A couple of weeks talking about statistics and probability and math optimization, and a couple of weeks talking about pandas and Python, PyData stack and databases. Just maybe one lecture covers databases. And then a couple of weeks talking about cloud computing and data infrastructure and ML tools and ML environment and data viz and ethics. That's it. And we have a quarter system, so we're a little scrunched. That's all we can cover in one course on data science. And that's basically just a gateway. So now you could branch off into a series of stats courses, viz courses, DB courses, ML courses, data ethics courses, and so on. So I think,
if I might jump in, I mean, I don't disagree. Of course, now you have to diversify in courses. However, the question going back about the books, right? I mean, the problem is that there are no books, there are no textbooks that cover this material. We do not have books that actually cover the essence of data processing that you can actually teach in a course.
I agree, Gustavo. There is no single book that covers what computer science is. So I don't think it's possible to have a single book that covers what data science is. Now, even on the systems aspects of data science, I mean, that's what I was saying. We need a new book that covers the systems aspects of data science. I have this course, the DSC 102. I really find a need for a new textbook to cover systems aspects of this. I think for undergrads, that is a need. Now, for a whole book on data science, I think there could be books that are more practitioner oriented, like what the O'Reilly folks do. That could give a whirlwind tour or something of that sort, but it won't be that deep. That's my guess.
But I'm not interested in data science. I'm interested in data processing. There are many people doing data science, if somebody has a definition for data science. But I'm interested in data processing. What are the concepts of implementing data management systems that are permanent, that are not that dependent on what is actually being done today? That's what I'm referring to.
That's the one I was also talking about. Systems for data science or systems for data processing, which takes some of these principles that we've covered in the relational world, like this. Straddling the memory hierarchy is a big part of what we've been doing. Parallelism is a big part of what we've been doing, parallel data computations, and optimization is a big part of what we've been doing. Auxiliary data structures and derived data, like materialized views, these are big parts of what we've been doing, and they are all model independent. None of them are specific to the relational model. They can be used in the matrix and tensor processing models. They can be used in semi-structured processing models. So these are sort of some of the principles that I wish we could cull out of, say, the Cow book or Sudarshan's book or all these other books that are tailored for relational systems, and create them as systems for data processing. That would be great.
But you just run exactly on the trap that I was setting. So why that book is not a cloud computing architecture book?
Cloud should also
that's where we're going, right? So instead of teaching data processing system, we're going to be teaching cloud computing architecture.
So cloud is basically a delivery method for resources. And so we should cover elasticity and fault tolerance and those sorts of things also as part of these core principles. I totally agree.
So Jana, I think you also had some thoughts on this data systems course.
Yes, definitely. So when we are talking about data infrastructure, I think we also meant about this data processing. And I have to disagree with Arun again to make things more interesting, that it's not about translating these concepts now to data science. It's about building the course that is of the essence of these principles, on top of which systems should be built properly. And I understand what Gustavo is saying, that it's difficult for us now to teach students one thing, while in the end we see that industry has built something else. But even industry makes mistakes, right? We can see that, they're proposing something because they are trading off, they're making some trade-offs, maybe at the scale of cloud. And then they're pushing that complexity to the developer, to the end user, right? As opposed to, embracing that and handling that complexity inside, which maybe is not the core thing to optimize for at the moment. But it is into what we could do is we could see on how these systems eventually, evolve, and what are the things that they rediscover. And this is a nice story to tell students these days, that, okay, so initially we started off with eventual consistency, and then we saw that, when building applications in the cloud, which is not what we were typically relying on when teaching, how traditional databases would work. And then these are the complexities that arise from that. And that's why we are now, we push that to the developer side, or at the moment now, Amazon is offering, read your own writes or read writes consistency, right? So these are the concepts, I think, that Arun is kind of duplicating the material that we already have, just tailored towards data science, where I in fact think that we should not be doing that. Right? Just put yourself, I'm not as experienced with teaching, but when I was taking classes, there were so many lectures on XML. Even I wrote my thesis about that in bachelor's, and none of that is present anymore, right? So should we really ride the popularity wagon, or should we really teach the fundamentals and concepts that transcend the popularity and will be still valid 10 years, 20 years from now on, right?
So one thing I would add to that, it's not duplicating at all. Relational model is not the be all and end all of the world. For matrix model, for tensor processing model, for semi-structured model, the principles are different. The philosophy is the same. Query optimization is query optimization. Nobody says relational query optimization is the only query optimization in the world, right? So that's what I mean. It's not duplication as in kind of like a wheel for an airplane cannot be the same as a wheel for a bullock cart, cannot be the same for a wheel for a bicycle, but it's a wheel all the same. If you teach the wheel design for a bullock cart or a bicycle to an airplane builder, it's not going to make sense. So we have to really tailor it to what workloads are we building it for? And are these workloads valuable enough? What is sort of the longevity and what is the potential of this? And I think there's multiple of that now. So that's sort of what I was saying. So it's not a sense of we need to stop doing the other. We really need to do this also. And I think there's something unified here that has potential. I just can't figure out what it is.
Thanks, Arun. So there's been a really interesting thread going through the chat. I'm hoping that Rachel will be able to help us bring it to the kind of the foreground, because I think there's a lot more that we can tease out.
Yeah, so I have to say I love the chat, and I hope that there's a way we can continue to have chats even when we can see each other in person, because this is a great out of bandwidth conversation. But with the conversation that I would like to focus on in the chat that we've been having is around what do students actually need in this introductory course? And there's a lot of things in terms of what they need, what they think they need, and what's actually feasible, right? So Luna brought up the great point that what students really need to be able to do in many cases is to be able to actually run an ML model, train it, and get it to do useful things. In my experience, there's an awful lot of background that those students are lacking before they can get to that point. They hear data science and they want to do data science because it's a buzzword, but they don't know what it means. They don't know what it means, and they don't have any idea about how they can actually structure it and do the things they need. So you need to have an awful lot of background in details that will allow them to understand, you know, here's just the basic stuff. Here's what data is. Here is the broad scope of things that you can do, right? And that background needs to happen before we can get to any of that. And if you're lucky, when you're done, then they can go and do some more interesting things. But it's just very hard, especially because these people may not have ever taken a programming course in their life, right? And so getting them to the point where they can do something useful is really, really tricky. It can be done, but you really have to scale down your expectations.
Thank you, Rachel. Alan, would you like to respond?
Yeah, but so I'm not sure that respond is quite the right word, but I think that it's actually not that hard for students to, for example, learn in one semester, learn enough programming to use the libraries that are out there. I mean, we don't get all our students to that point in the first introductory freshman data science, but we can get an awful lot of them to the stage where they can build a very simplistic regression model. You know, I mean, it's a couple of lines. They may not understand quite what the lines are doing, but you know, you call one of these Python libraries and it builds your model and applies it to data. The hard bit is getting students to recognize that this is not a very good model that they've just built. And that's a much harder job. So I think evaluation is something that we have to be teaching. But equally, I think we need them to understand, I mean, it's not just the model at the end, it's the whole life cycle. And there are concepts all the way along. So, you know, my goal in that freshman course is not students who are going to be professionals, but the sort of students who are going to be doing projects in their chemistry major or their biology major or their history major, where they've got a data set and they want to do some processing of that data set. And there, I think there are a huge number of data management concepts that those students need in that situation. They've got a bunch of files, but they need to know what's the metadata for this file and why do I need to make sure that the metadata stays in sync with the file. And they need to know about the different ways you could actually organize the data, and they need to know about data quality. It's fairly superficial, but you want them to be thinking about their data as an asset. I think that's the heart of it, and that assets need to be managed, and that they're going to have to manage those assets. And we can teach at least an awareness of some of that in a single subject.
Thank you, Alan. That's a very encouraging perspective on it, and I really like the. I've heard from a lot of people that sometimes we produce students who early on don't bother to look at the data, don't bother to look at the results, and you get garbage in, garbage out. So that seems like a very good point about a seemingly non-technical, but actually absolutely essential part of what we're trying to do. Luna, would you like to respond to Alan and Rachel?
So I would like to have a couple of points. So first, I think I agree that people need to learn some preliminaries to be able to, for example, do something end-to-end, train models, etc. But oftentimes it is not really that much. Again, this is with the assumption that if we have a single course in data science, then we teach the basics about, believe me, you need SQL, you need some basic programming languages, you need those preliminaries to eventually be able to train some models end-to-end. And the second thing is, amazingly, data management, data quality, data exploration, all of this is super important in this end-to-end process, because training models, I mean, eventually just train a model and sort of tune the parameter, that's just a small part. And then you prepare the data, and then you sort of try to understand the results. You come back to clean up the training data. All of this is data management. And through that process, people will understand, hey, we need to know how to manage the metadata, how to improve the data quality, how to do the data exploration, evaluation, and so on. And the third thing is, if we are able to design the course to use data that is closest to real world data, then this actually helps people to understand what we normally teach in textbooks might be a little bit away from the real life, and what they face eventually in terms of massaging the training data, measure the final results. This is different from the textbooks. There are so many practical problems they need to solve to have really reliable models. So that's the point. And I agree with some of the comments that, well, this might be for some particular set of companies' use cases, but one is basically recommendation is a classification model, and NLP is kind of a search ranking model, and they cover a lot.
Thank you, Luna. And I think we are basically running right up to our time limit. So I want to first note that I think there was a lot of engagement in this, which was fantastic. There's a lot of interesting stuff in the chat. I think that will be recorded and posted. But what I really hope is also this level of engagement, we can find a way to continue it past this discussion into something that might actually be useful for all of us as we think about teaching data science, computer science, databases, data, whatever it is, depending on our specific needs. One of the other, I think, interesting pieces was just how much diversity there is in everybody's setup. Before we end, I want to really thank our panelists, Jana, Johannes, Rachel, Arun, for really giving us a lot of interesting fodder for thought. And also everyone in the audience who actually participated. This was a lot of fun. The fact that we're running out of time, I hope, is an indicator of just how passionate everybody is about this. So thank you all, and I want to yield the floor to Pinar, who has an announcement.
Yeah, thanks, Zach, and thanks to everyone. So yeah, we now I invite Ellen and Uwe for the VLDB 2022 sneak peek. presentation. Where are you here?
Yes, I am. Hello. I would love to show something, but whoever's currently sharing the screen, I can't share.
Sorry about that. Hopefully it's working.
Yep. Can you see me too? Wonderful. Okay, welcome everyone.
Just a second, Uwe, just a second for the visuals here.
1, 2, 3. I can see that I'm sharing, I thought. Yep.
I think it's just getting it on the screen in the room.
Yep. Wonderful. Okay. Welcome everyone. It's my great pleasure on behalf of the organization committee of VLDB 2022 to give basically the final presentation of VLDB 2021 and giving a bit of an overview of what you can subscribe to with your publications for next year when we are organizing VLDB in Sydney, Australia in early September. We have a very nice venue in basically the middle of the city, the International Congress Center, which is located at an area called the Darling Harbour, which is part of the harbour, as you can imagine. We have one hotel, actually multiple hotels just in walking distance. The main ICC hotel, the Sofitel, is literally, you're walking across the plaza and you are in the conference venue itself. There are heaps of other accommodations and restaurants in that area too. Darling Harbour is well known for being one of the areas where you have a lot of restaurants and opportunities to go out. If you go a bit further up that direction there, you come to King Street in Barangaroo, which is a brand new area with a lot of restaurants. On the other side of that area, even also close with just 5 minutes walking away is Haymarket, Chinatown. We also get Japanese, Thai food, Vietnamese, whatever your heart is for. And the city center is close by, and behind the CBD, we have the well-known landmarks of the Opera House, Circular Quay, the Rocks, the Botanical Gardens. So everything basically is available with public transport, which is close by, or simply walking within 10, 20, 30 minutes. The venue itself is a brand new, relatively brand new International Congress Center, opened in 2017, and as you can imagine, recently not very much used. So everything top notch. We opened up to the Darling Harbour area and with a look into the city from the conference venue itself. We have a nice main plenary theater there where we can fit the whole VLDB conference and have top modern infrastructure available to host the event and the main plenary sessions there. There are a number of breakout rooms close by, just across the foyer of different layouts, different sizes, and all with modern technology, of course, included. And we have a foyer area where, most importantly, we can network with each other and find quite side spot and check our email. And of course, we will look after the catering for you and have a lot of options for that in the venue too. In case you can't make it in person to Sydney, as unfortunately we couldn't make it this year to Copenhagen, we will organize VLDB 2022 also as a hybrid conference. So that means it is also possible to do a completely online participation in VLDB 2022 next year, as it is possible this year. And we will provide a the best online experience we can organize for you with a tight integration into the community, which is actually on site in these different venues and rooms there. We're closer to the start of the registration deadlines for the conference. We will provide more information on our website on how that exactly will get organized. Of course, we would hope that you actually come in person to Sydney and have the direct personal communication and networking during the conference. And if you do so, there are heaps of different attractions, landmarks, museums, etc. close by, which you can enjoy while you are in the city. And should mention all of that, what you see here basically is, again, in walking distance of the actual venue, what you can reach them. Perhaps a bit further out are the beaches, but they are there. Sydney is a coastal city with a beautiful harbor and also a lot of very interesting and great coastal beaches. For example, here the well-known Bondi Beach, which is perhaps an hour or so away if you get with public transport here. If you go a bit further out around the city, you could go to the Stockton Beach, which is one of the largest sand dune areas in the world, I think 30 kilometers or longer. We have the Blue Mountains area behind the city if you're interested in bushwalking. If you're a bit more interested in relaxing, perhaps one of the wineries in the Hunter Valley, just an hour and a half away from Sydney to the north. If you're lucky, perhaps you see even a kangaroo there. Or two, and you could go also beach walking in, for example, the Royal National Park south of Sydney. So there are heaps of national parks all around the city, and I think that is a very great opportunity to socialize and explore the surroundings of Sydney just beyond the actual conference itself. Just to mention, we are in the Southern Hemisphere, obviously. So in early September, we have spring in Sydney, which is actually a pretty nice time to be in the city. Average temperatures, max temperatures are in the range of 20 degrees Celsius around that time. And don't ask me what it is in Fahrenheit, I'm sorry. For example, this weekend, we are looking at 22 degrees Celsius for the forecast. So yeah, that is definitely something where you can really enjoy the city, and we have a lot of sunshine during that time too. So I can't guarantee you that it's not raining sometimes in between too, which we actually normally appreciate here in Sydney. We'll also get some rain. Okay, and with that, I hope that we could encourage you to join us in VLDB 2022 here in Sydney. Pina, if I do have a bit of time, I could just briefly show us a final event here, a bit of an overview video about Sydney.
Yes, sure. If it is 2 or 3 minutes. Yeah.
Okay, no worries. Okay, so with that, thank you from my side, and I'll show you a bit about Sydney and the surrounding here. Wait a second. I'm sure you didn't hear anything, right? Share sound. I hope that works now. Okay,
Yeah.
thank you.
Yeah, thank you as well for this presentation. So looking forward to it. Let's hope that we can travel more easily by that time. So thanks everyone again for the great session overall, and I guess this also ends our conference. I want to thank, like in general, all the attendees, participants of the conference, whether online or in person. Like this has been, I mean, it was an experience that I think taught us a lot overall in terms of how we run conferences, and I was really glad to see how many people were willing to help during the conference, before the conference. So thank you very much, and see you. I mean, tomorrow there are workshops, but see you next year otherwise.